Hey everybody, so here we are with another circuits problem. Alright, this one's a diagram. It's not, well, it is a circuit, but it's more of a diagram than anything. So I have these two things, A and B. Both A and B are batteries. Let's say this represents a car connected to another car. Let's say a car is getting jumped. Okay, so car A and car B are connected with some jumper cables that's what these two wires right here represent. Alright, so there's the interaction between their batteries. Okay, they say car A has its battery polarity is like this, minus to positive, and car B's battery polarity is plus to minus. All right, and they're going to say the current passing between the two cars goes in this direction. So it's going in a counterclockwise direction. So it's going to pass at the bottom to the left, and then the top is going to, pass at the bottom to the right, and pass at the top to the left. All right, in a counterclockwise fashion. They tell you both voltages, all right, V, since they're both V, both voltages are 9 volt, they're both 9 volt car batteries, and there's 2 amps of current passing between them, okay? So with this information right here, they want to say which battery is the dead battery, okay? So this is our problem. All you've got to do is think about it like this. The dead battery is absorbing power. It wants to absorb energy, okay? Power/energy. And that is going to be our ticket to getting done. Okay, so if the dead battery is absorbing power or energy, then we can use our understanding of power. All right, we know what power is in circuit theory. Power is equal to V times by I. Remember, where it can be positive or negative because of the passive sign convention. So when power is positive, we like to say it's absorbing power. And when power is negative, we like to say objects are delivering power. Okay? So all we're trying to see is which battery has the positive power. Okay? As long as we know which battery has the positive power, we know which battery is absorbing, we know which battery is dead. All right? So all we have to do is do a power analysis on both batteries. Okay? So a lot of students will say, well, the power is the same through them both. Yes, the power is the same, but the direction of the power is not. Because power for both of them, if both of them are 9 volts and 2 amps, then the power for both of them is going to be 18. But it's more than just that. You got to look at them and then consider the passive sign convention. Okay, so I'm going to say the magnitude of the power for A is the magnitude of the power for B. But, and this is the big but, passive sign convention dictates sign. So let's just get a look at what happens with the currents. So for battery A, I guess I'll do it in blue. For battery A, all right, the current's going to come like this. It's going to come down. It's going to do something like that. All right, the current's going to go from negative to positive. Okay, that is backward to the sign convention. All right, because it's doing this. Current minus to positive, and because of that, the power on A is equal to 9 times 2 voltage times by current, but it's negative because it's backward, which gives me negative 18 volts. Because of that, I know I know A is delivering power. Okay, 18 delivered. I put volts, shame on me, that should be watts. 18 watts delivered. Okay, well, if A is delivering, then B has to be absorbing, which means B is the dead one automatically. We understand that B is the dead battery, but let's just test B. Just do the math on B just to be 100% sure. Well, the battery B, if you look at the current, it's going to keep going, it's going to pass through, it's going to come and do that. The power is going from plus to minus on B. Okay, plus to minus. The current passing from plus to minus is definitely forward, which means whatever we calculate is going to be the answer without having to do any negatives. So it'll just be 9 times by 2. Positive 18 watts, 18 absorbed, which means that B is the dead battery. Okay. So, with that being said, this is our answer. And the answer was not that hard to get at all. As long as you know voltage and current, you can find the power. And every time you have to use a quantity that involves on current and voltage, such as power, such as Ohm's law, equations that have power and voltage. The equations that have current and voltage in the same line. You've got to check the passive sign convention to see if there are any negatives that need to be drawn onto your equations, just because it's backward or something like that. All right, so. Please get into the habit of doing this. Whenever you have to find that quantity, always check passive sign convention, always, because we're going to start coming up with shortcut analyses. And the shortcut analyses do not include passive sign convention. You will always need to check to see what's happening there. All right, so that's our answer, and I hope this helped.